Alterations. Please welcome Katrin Preller.
So thank you so much for having me here, and thank you so much for the organizers for putting together this wonderful conference, which has been a pleasure and a great pleasure so far. So as I said, or as I was introduced, I will talk about our studies that we've run in Zurich. And as you know, Zurich is in Switzerland, and Zurich or Switzerland is not only famous for its mountains and chocolate, but also for the discovery of LSD and the synthesization of Psilocybin. So I'm going to skip the details on this now. Sorry. But these are the two substances I'll be talking about, Psilocybin and LSD. Dave has already introduced the pharmacology of that, so I won't bother you with that anymore. But, sorry. But these two substances share a lot of similarities, but they also are different regarding their pharmacology, also the length of the effects that they are inducing. Yeah. So so LSD, an LSD trip lasts up to, well, it lasts at least 8 hours, might even be longer for certain participants, also depending on dose, obviously, whereas with psilocybin, our participants are usually rather sober after about 6 hours. We know that these substances are, in general, rather safe compared to other substances, which means they are not inducing any addiction. You cannot necessarily physically overdose. However, we need to be careful about set and setting, and this has been discussed in detail already. We are running these studies in, So we are running these studies in Zurich at a hospital where we also try to take good care about the setting. So we were running these studies in a living room-like setting. However, the data that I'm going to present are also, a lot of them are acquired in the scanner, which kind of needs special attention if you want to run studies like that. So I will quickly introduce you to the effects that LSD and psilocybin induce at the doses that we administer, and I'm sure that most of you are very much familiar with what these substances do. However, at the doses that we administer, one of the things that is most evident are obviously visual alterations. And this slide, which I like it a lot, it's done by a very dear colleague of mine, Candace Lewis, and I think she put together really nicely what these substances do. So what might happen is that colors might appear brighter, colors might change, things might get a little bit blurry, or things might start moving around. Obviously, this is different for every participant that we have, but it's important to know that at the doses that we administer, we're not talking about real hallucinations. We're talking about pseudo-hallucinations or illusions like this one. But the thing we are actually mostly interested in, at least for the data that I'm going to present now, is the subjective alterations of self-experience, which these substances reliably induce. So I'm kind of, here we go, now it works. So we know that LSD as well as psilocybin, they induce these alterations in visual perception. However, they also reliably induce alterations in self-perception, which are incredibly interesting to do research on, because these substances give us the opportunity, the unique opportunity, to alter self-perception and therefore being able to investigate the underlying pharmacological effects, which is really hard to do otherwise. So this brings me to the topic of my talk. So we've been talking a lot at this conference about the research that is going on in a clinical setting right now, and how psilocybin or even LSD can be used to treat psychiatric disorders. And this research obviously is incredibly interesting, and we are currently running a study at Yale as well as in Zurich to look at psilocybin as medication. However, for the talk right now, I want to focus on the work that we've been doing with healthy participants. And the reason for this is because, as I said before, I think psychedelics offer this unique opportunity to study clinically relevant phenomena that are otherwise hard to study, as I said, self-experience, but also social cognition, as we'll see, or for example, the underlyings of consciousness and, in general, how our brain works. And I think that increasing the mechanistic understanding and the pharmacological understanding of these substances is also important to eventually uncover the full clinical potential. So there are two questions that I want to address today. And the first is, well, how do psychedelics act in the brain? And what is their pharmacology and neurobiology? And the second question I want to address is, what can we learn from psychedelics about the neurobiology of self-experience and social cognition? And I will go into detail later why I think this is an important question. So let's look at the first question. So for you to be able to understand what we are doing, I wanted to give you a brief introduction into how these studies look like when we do them in Zurich. So I will talk about two particular studies. The first one has been conducted with psilocybin. The second one with LSD. I'll introduce you to the design of the psilocybin trial first. So what happened is we had, in this study, 32 participants. They come to us, they undergo a screening visit where we talk about them, about their motivation, why they want to participate. We make sure that they are physically and mentally healthy, and then we have the first test day, and participants come to us. They, in this study, went to the MR scanner first. We took them out of the MR scanner, we gave them the substance, which was either placebo or psilocybin. All of our studies are within subject designs, meaning that all participants undergo both drug conditions in a randomized order. So we wait for an hour, which is what we know that psilocybin will induce effects after 60 minutes. After 60 minutes, we put them in the scanner, do certain paradigms. We take them out of the scanner. They answer some questionnaires. They do some behavioral testing. And about 300 minutes after administration, usually people are sober enough and are allowed to go home in the company of a friend or family member. So as David Nichols already told you, so I again won't go into detail here, is that the pharmacology of LSD is a little bit more complex than the one of psilocybin. So LSD stimulates quite a few receptors, and we wanted to specifically investigate the serotonin 2A receptor, the contribution of the serotonin 2A receptor in this particular study. Because before we did this study, we knew from the animal literature that the serotonin 2A receptor and the dopamine receptors are contributing to the effects of LSD in animals. However, this hadn't been shown in humans at that point. So what we did is we blocked the serotonin 2A receptor using ketanserin, and then gave people LSD to investigate which symptoms are left after we block this particular receptor. So this is the design of the LSD study. So first, participants, again, were screened. They were included in the study. They came to the lab. And they were administered the first substance, which was either placebo or ketanserin. Then we waited another hour, and then they received the second substance, which was either placebo or LSD. So basically, our participants were at the clinic 3 times. They received either just placebo, or just LSD, or ketanserin plus LSD. So these were the 3 drug conditions everyone went through. We waited another 60 minutes, then we put them in the scanner. We took them out of the scanner, they rested a little bit, they did some behavioral testing, and the advantage of LSD, which kind of also is its disadvantage, but in that particular case, the advantage is that the effects last incredibly long. So we put them back into the scanner and did another couple of tests. did another couple of tests. And for the LSD study, since the effects lasted so long, usually the participants stayed at the hospital overnight and were supervised and then were released home the next morning. So let's look at the first results of this study. So what we see here is the effects that LSD is inducing in pink. So this is not surprising at all. LSD does what LSD is supposed to do, right? But the interesting part here is something that is actually rather hard to see because it's down here, and it's the yellow bars. And as you can see, the yellow bars are not at all different from placebo. And the yellow bars are the catanzerin plus LSD condition, meaning that catanzerin blocking the serotonin 2A receptor reduced all subjective effects to the level where participants could not differentiate between catanzerin plus LSD and placebo. So the subjective effects, at least at the dose that we administered, seem to be completely dependent on the serotonin 2A receptor. And the same is true when we look at the effects over time. So it's not like there is a first phase and the second phase, so there is just nothing going on in the catanzerin plus LSD condition. So now looking at the neuronal effects, so this is basically your brain on LSD. And there are two important parts when we look at this slide. The first one is the pattern that LSD induces, and the second one is the pharmacology. And I'll talk about the pattern first. So what we did here is we investigated global brain connectivity. So this is a functional connectivity approach. And the important part here is that the areas that you see in yellow and red and warm colors, they are highly connected under LSD, significantly more highly connected than under placebo. And the blue and cold colors, they are less connected in the LSD condition than under placebo. And the ones who are used to looking at these brain maps will realize that the yellow areas are the ones which are responsible for our sensory perception, be it from the external world or from the internal world. So our sensory areas are highly connected, are talking to each other like crazy. However, the blue areas show that the areas which are responsible for integrating these experiences, be it internal or external, these areas are loosely connected, much less connected than under placebo. And I think that makes a lot of sense if we think about the effects that LSD or psychedelics in general are inducing, because we have this elevated experience of the world, of our internal world, of the external world. However, we are not necessarily able to integrate it as well as usually. So this might explain why things, look new to us, why things might make more sense or less sense than usual, because we are integrating them in a different way, in a more loosely connected way. So the next important part of this slide is the pharmacology behind it, because obviously we had this third condition where things were blocked by catanzerin. And this is basically what you can see down here. So catanzerin, again, completely normalizes the effects that LSD is inducing, no significant difference here. So on a neuronal as well as behavioral level, we see that this blocking the serotonin 2A receptor just removes the effects of LSD. So David Nichols was already talking about a paper that recently was published on comparing functional maps of the brain under psychedelics with with receptor expression maps. And this is basically what we did here too, and it's great because our results are very similar to the ones that Dave showed before. We chose a slightly different approach though. So we took data from, it's called the Human Allen Brain Atlas, which shows us the localization of the gene expression of these receptors. So we have different gene expression maps, and what we did is we correlated those maps with our functional connectivity data. And what we see here is, again, that the serotonin 2A receptor gene expression map is highly correlated. So this is what you see here, is highly correlated with our functional connectivity data much higher than all the other receptors that we looked at. So again, this makes very clear that obviously the serotonin 2A receptor is an important target of the effects of LSD. And in case you were wondering, we also looked at psilocybin. This is still work in progress, but our first results show that the functional connectivity looks very, very, very similar in the psilocybin condition as in the LSD condition. So this seems to be a common mechanism of psychedelics, at least as we've shown for LSD and psilocybin now. Okay, so my last 2 slides on how psychedelics work in the brain is, I won't go into detail here, but Mark Geyer and Franz Vollenweider suggested a model how psychedelics work in the brain. And briefly, what they suggested is that the ventral striatum loses its control over the thalamus. The thalamus opens up a filter so that information is going to the cortex more or less unfiltered, which is then inducing a sensory overload that leads to the effects that people are experiencing under psychedelics. And we found a method to test this particular hypothesis, this model of how psychedelics work. And we used effective connectivity. Effective connectivity, compared to the other methods, can tell us which area in the brain drives another area. So it's not just areas are correlated, but we can actually say, well, the connectivity from place A to place B. And this is what we've done here. And basically, we chose these areas, which are important areas for the model that Vollenweider and Geyer have proposed. And what we see here is the red arrows here are increased connectivity under LSD, and the blue ones are decreased connectivity under LSD. And what we see is, indeed, we see decreased connectivity from the ventral striatum to the thalamus. We see increased connectivity from the thalamus to the PCC. However, while this is in line with what Mark Geyer and Franz Vollenweider have suggested, we also see that, well, it's probably not that simple. So for example, from the thalamus to the temporal cortex, we see decreased connectivity. So most of this is very much in line with this hypothesis, but it's not like the thalamus is just undifferentiatedly sending information to the cortex, but it seems like it's sending information to particular areas of the cortex. Okay, to briefly wrap this up, we've seen that LSD induced subjective as well as neuronal effects are dependent on the serotonin 2A receptor. We have seen that LSD as well as psilocybin induce increased integration in sensory and somatomotor areas, but at the same time reduce the integration in more associative regions. We also have seen that there are alterations in effective connectivity in LSD-induced states that are at least partially in line with the thalamic filter model. So this is basically the summary of what we have found, how these substances work in the brain generally, what is their neurobiology and their neuropharmacology. Which then brings me to my second question, which is, well, the self and social cognition. So why bothering studying self and social cognition? Well, we know that alterations in self-experience and social cognition are really core symptoms of many, many psychiatric disorders, and they influence the development, progress, and treatment of psychiatric disorders. In particular, because if you think about someone, you know, where social cognitive processes don't work that well anymore, well, they will show social withdrawal, which is evident in almost every psychiatric disorder. So you can also imagine that someone where, you know, we treated most of the symptoms, he goes back to work, but he will still have difficulties keeping a job or getting a job if he's still acting socially awkward, right? And the problem with this is that currently we don't have any medication and we don't have any understanding of how these processes work in the brain. So we basically can't treat them at the moment. And this is why it's important to investigate the pharmacology and the neurobiology of these processes. And we started off with, first of all, the idea of thinking about how LSD affects self-perception. Because as you will see, self-experience is not necessarily independent from social cognition and how you perceive others. So the first thing that we did is we looked at something that has come up in this conference before, the potential of altering self-relevant processing and meaning making, which is an important part also in a lot of therapeutic approaches. So what we did is we had people bring music to the lab, music that was particularly meaningful to them. What we did is we matched neutral music. So it was kind of the same style, but people hadn't heard the music before. And we had meaningless music. And I now don't want to offend anyone, but it was mostly free jazz. And so for most people, this is very difficult to approach. We had a second category in just in case, we ended up having a jazz musician in the study. But so for most people, it was free jazz. Really hard to approach. And we played them, we played this music for 20 seconds in the scanner, which is what you need to do to get a good signal on the scanner. So you can't just play the whole piece of music because this will screw up your data. We asked them how meaningful was that particular 20 seconds for you, and then we played the next music piece. And this is the results of this. So what we see again, first of all, gray and blue, nothing happening in the LSD and ketanserin plus LSD condition. We see, obviously enmeaningful music is meaningful, meaningless music is not meaningful. However, the interesting part here is that LSD significantly enhanced the perception of meaning in the neutral as well as the meaningless condition, not so much for the already meaningful music pieces. Then we looked at the neural data, and what we've seen here is basically exactly the same pattern as we've seen in the behavioral data. So we get a greater reaction of brain regions that are relevant for self-processing, self-relevant processing, meaning attribution. So these are the cortical midline structures, and as you can see here, we get a significantly greater bold signal, greater reaction for the meaningless category in the LSD condition than in the placebo condition. And again, when we compare this with LSD with the ketanserin plus LSD condition, we basically see the same pattern here, which means that, under LSD, there is some kind of meaning generation to stimuli that were previously meaningless. And this is dependent on the serotonin 2A receptor because it got blocked by ketanserin. However, there's something else we saw. So if we compare ketanserin plus LSD to placebo, we see an enhanced reaction to already meaningful stimuli. And again, we know in this particular condition, the serotonin 2A receptor was blocked, right? But still, LSD stimulates a range of different receptors, not just the serotonin 2A receptor. And the most likely candidate here is probably the dopamine system if we look at the animal studies. So I'll quickly wrap this up. So first of all, we've seen that LSD increases the attribution of personal relevance or meaning to previously meaningless stimuli. And this is attributable to the serotonin 2A receptor because it got blocked by ketanserin. We also seen that here, ketanserin plus LSD modulate already meaningful stimuli, which might be due to the dopamine system. So the serotonin 2A receptor system might be important for the generation of meaning, whereas the dopamine system might possibly be important for the modulation of meaning. So the next thing is we took this one step further and we're interested, okay, there is obviously something going on with, self-processing, self-relevance attribution. How does that relate to social cognition, which is this major problem in psychiatric disorders? And we went for a task which is investigating a very, very basic process of social cognition, which is called joint attention. So joint attention is induced when I look somewhere over there, and most of you will follow my gaze. However, if we are in a direct conversation, I look over there, and you will look the other way, this will feel kind of weird. However, we also know that this very, very basic process is important for the development of higher cognitive or higher social cognitive processes, such as knowing what the other person thinks, empathy, etc., etc. And also we know that this basic social process is impaired in disorders such as autism, but also addiction, for example. So what we did is we had our participants lying in the scanner here. He was interacting with someone outside of the scanner, which was actually a virtual avatar. And we underwent two different conditions. The first one is our participants were the ones inducing the social interaction. And the other condition was that our other participant or our avatar was inducing the interaction. And usually, if we do this under placebo, we see exactly the brain areas lighting up which are responsible for differentiating ourselves from other people. So this is a good paradigm to look at this differentiation between this is me, this is the other one. And the other two conditions where we were either doing joint attention, so both people looking at the same object, or non-joint attention, which is this very basic social process. And the beauty of this paradigm is that it is possible to investigate these things in real time. So people are not just looking at photos of other people or whatever, but they are actually within this interaction. They're actually doing something and interacting in real time with, unfortunately, is still an avatar, but they are doing this interaction. So these are the results, very briefly. What we have seen here is that LSD significantly reduces this differential activation for self and other, meaning so the differentiation between this is me, this is the other one inducing this interaction is significantly reduced. And it's significantly reduced when we look at LSD versus placebo, as well as when we look at LSD versus LSD plus cadenzarin. Again, no difference between the LSD plus cadenzarin and placebo condition. So this decreased differentiation between this is me and this is someone else is again dependent on the serotonin 2A receptor. And when we then look whether this translates to problems or alterations, let's say, in the social cognitive processes, we again see here that LSD also reduced the usual reaction to joint attention versus non-joint attention. So what does this mean? Oh, no, sorry. So this differential effect, particularly in the PCC, is correlated with changed meaning of percepts, which I think makes a lot of sense because changed meaning of percepts captures basically our relationship to our environment, and this is related to this decreased differentiation between this is me and this is another person. So, but again, so what does this mean? So first of all, we have seen that LSD alters self-experience and at the same time social cognitive processing in these areas of the so-called social brain. We also, using this paradigm, we could also see that inducing alterations in self-perception is an important part or has effects on social cognitive processes. So these two things, like how do I perceive myself, how is myself processed in an integrated way, has an impact on how I perceive other people. So, if you want to translate that to a clinical setting, you could say, well, social cognitive abilities are altered in patients with depression. So we also know that patients with depression have this increased self-referential bias. So if we lose this self-referential bias, for example, with serotonin 2A agonists, this might also help their social cognitive abilities. But then again, we also know that there are other people who suffer from, for example, psychotic disorders like schizophrenia, and they already have this very disintegrated sense of self. So their social cognitive abilities might benefit from giving them serotonin to an antagonist, so exactly the other way round, to have a more integrated self and hopefully help their social cognitive problems as well. So I'm coming to my last part, which is also changing gears and going to the psilocybin study. So we knew from other studies that psilocybin is modulating how we perceive negative experiences in the amygdala, also behaviorally, which might be a mechanism of how psilocybin might help depressed people, because we know that depression induces an enhanced and increased processing of negative stimuli that might be normalized by psilocybin. However, what we didn't know is whether these kind of artificial situations that we have induced in the scanner, we had people looking at, negative pictures, for example, whether this also holds true for a more everyday relevant process like negative social interaction. And we know that a lot of psychiatric patients are, for example, ostracized from society. They experience a lot of social rejection. And we wanted to see whether psilocybin is able to modulate this process. So what we did is we had our participants lying in the scanner, and he or she was introduced to Michael and Sarah. So they physically met before we put them in the scanner. And they were playing a game where they could throw a ball around. So our participant is throwing to either Michael or Sarah, and Sarah is playing with Michael and our participant. And what then happens is, at one point, Michael and Sarah will just stop playing with our participant. They won't throw the ball to him anymore. So you might now think, well, how relevant is that, right? You're lying in the scanner, and Michael and Sarah don't want to play with you, so what? And so the thing with this paradigm, even though it might sound a bit silly, is that this paradigm has been used over and over again, and we've seen that it indeed induces this feeling of social rejection, and it also induces a certain brain signal, which is now labeled social pain signal in the ACC. So reliably, even though it might really not matter that much, reliably it induces this feeling of being rejected, as well as induces this signal in the anterior cingulate cortex. And when we do the same paradigm with patients in borderline personality disorder, we see that they show this increased reaction in the ACC, as well as we do this when we do this with depressed patients. So what does psilocybin do? Well, first of all, we asked participants, obviously, so how excluded did you feel during your rejection phase? And what we see is, well, they didn't feel as excluded as under psilocybin. Now you might think, well, who cares when you're under psilocybin, right? So we had I think about 20 control questions, and none of them were significantly altered. So people were perfectly aware that they were excluded from this game. They just said wow, it didn't feel that bad as under placebo. And when we look at the brain activity here, we see exactly the social pain signal, which is decreased under psilocybin compared to placebo. Now, again, as I said, we want to find out what are the mechanisms behind that, and how can we use that, for example, to develop new medication and go one step further. We also looked at the signal. So we also looked at magnetic resonance spectroscopy, which basically gives you an idea of the neurotransmitters and molecules that are in this particular brain region and how they are influenced by psilocybin. And we saw that there is a neurotransmitter called aspartate, which is highly correlated with the signal here. So this particular neurotransmitter might also play a role in these kind of processes. So the last thing we looked at is how do psychedelics influence empathy? There are different kinds of empathy. Cognitive empathy, which is just, well, I know what you're thinking or I know what you're feeling, but it doesn't mean that I necessarily need to feel the same thing. Whereas emotional empathy is, I actually feel with you. We tested both things, and we saw first of all, we saw no difference in cognitive empathy. So participants weren't getting any better with knowing what the other person is feeling. However, they didn't get worse either. So this is good for us because that means we have a control, so people were actually doing the tasks, and they were doing it correctly. And the thing that we saw here is, well, we see a difference, a slight enhancement, but a significant enhancement of emotional empathy. So people were feeling more with other persons, which is good because so far, except for MDMA, we don't have a lot of pharmaceuticals which are able to increase social processes, like empathy, for example. The other thing that we did in this study is we also looked at, well, does this then translate to moral decision making? So if people feel, if people are more empathetic, they should, choose differently in their behavior and act more morally. However, we did not find any effect on moral behavior, which it just might be that even though people are more empathetic, they just don't act more morally. The other reason for this might be that, well, behavior is something that doesn't just change from one day to the other, and all of these measures were measured acutely. So maybe moral behavior is something that changes over time and that we need to reassess a couple of days later, which we haven't done yet. So all of these are acute effects. But it would be interesting to look at whether we find an effect a week or 2 weeks, 2 weeks later after we gave them psilocybin. Okay, so I will quickly wrap this up. So we have seen here that LSD-induced behavioral and neural alterations via the serotonin 2A receptor. We've seen that LSD as well as psilocybin induced the synchronization of sensory functional networks and the disintegration of associative networks. We've seen that LSD induces changes in effective connectivity, which support at least partially the thalamic filter model. Going to the paradigm studies, we've seen that LSD increases the attribution of personal relevance or meaning via the serotonin receptor in these cortical midline structures. We've seen that psilocybin and LSD both modulate social cognitive functioning, and that alterations in self-perception play an important role for alterations in social cognition. And the last point, the serotonin 2A receptor system as well as the aspartate system play a particularly important role in these effects. So I think understanding these neuromodulatory and biochemical substrates of social cognition can really help us to understand social interaction in a more mechanistic way, which is something we desperately need to be able to treat difficulties in patients. And on the other hand, I also think that really increasing our mechanistic and pharmacological understanding of psychedelics is important to uncover their full clinical potential, to be able to leverage psychedelics in therapy in a way that makes sense because we know what exactly we can do. And this is important for the treatment of patients and the application of psychedelics in the clinic. However, there is still a lot of work that needs to be done. So again, we need to translate some of these things to patients to see whether that holds true in a patient population as well. We still need to develop biomarkers that hopefully we'll be able to predict who psychedelics work for, who they don't. And as I said, one of the things we're doing right now, which goes into this direction, is we're currently running, or we will hopefully soon be running a trial in depression, a placebo-controlled trial in depressed patients with participants in Zurich. We hope to start that soon. And this is the last thing I want to share today. We are actually currently doing a crowdfunding campaign on wemakeit.com. So if anyone or anyone you know wants to contribute to this study and help us that this study will happen, so we can hopefully uncover the full clinical potential and develop biomarkers. We are very grateful for your support. Thank you very much.